Section 12.3 is on probability and odds. Hopefully you already did Section 12.3.0, which was an introduction to probability and odds, which will make this make a lot more sense and be a lot easier for you. So let's read this. It says, in California, the likelihood of selecting a winning lotto ticket numbers in the Super Lotto Plus game is approximately 1 chance in 41 million. In contrast, the likelihood of being struck by lightning is about 1 in 500,000. Comparing the likelihood of winning the Super Lotto Plus to the likelihood of being struck by lightning, you are 80 times more likely to be struck by lightning than to pick the winning the California lottery numbers. So the likelihood of the occurrence of a particular event is described by a number between 0 and 1. You can think of this as a percentage between 0% and 100% inclusive, meaning it could be 0% and it could be 100%. This number is called the probability of an event. An event that is not very likely has a probability close to 0. An event that is very likely has a probability close to 1. For instance, the probability of being struck by lightning is close to 0. However, if you randomly choose a basketball player from the National Basketball Association, it is very likely that the player is over 6 feet tall, so the probability is close to 1. So again, as we saw in the previous section, an introduction, every probability has to be a number of value between 0 and 1. Nothing makes sense if someone said the probability of an event is 1.5 or 3. None of those numbers make sense. It always has to be a number between 0 and 1. So that says because any event has from 0% to 100% chance of occurring, again we say probabilities are always between 0 and 1. Okay, how are we going to write them? We're going to write them as a decimal approximation or reduced fraction. We are always going to assume that it's a reduced fraction unless otherwise stated. Again, remember if you have a probability of 1, that means the event must occur. Probability of 1 means must occur. And a probability of 0 means it cannot occur. Probability of 0 means the event cannot occur. Okay. So it says probabilities can be calculated by considering the outcomes of experiments. The sample space of an experiment is the set of all possible outcomes of the experiment. For example, consider tossing a coin 3 times. So when we tossed a coin 3 times, we got the 8 total possibilities listed here, which are heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, tails, heads, heads, and tails, tails, tails. So it says a single die is rolled once. What is the sample space for the experiment? Anytime it says sample space, it's just saying what can happen. If you roll the die one time, you could have a 1, 2, 3, 4, 5, or a 6. Now it says a coin is tossed twice. What is the possible outcomes or sample space for this experiment? Remember we did this in the previous section. If you have 2 outcomes, list one of them on the vertical axis and one of them on the horizontal. Create a chart. Looks like we would have heads, 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 tails, tails, heads, and tails, tails. Those are 4 possible outcomes. Again, that was heads, 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 tails, tails, heads, and tails, tails. Formally, an event is a subset of a sample space. Using a sample space of example 1 being rolling a die, meaning it could be any of the faces from 1, 2, 3, 4, 5, or 6, here are some possible events. Well, one of the events that we could want is an even number. So of those 6 possible, which ones are even? Well, it'd be 2, 4, and 6. So if I said what's the probability of getting an even number, you would then take the number of ways it can occur, which is the 3 ways, it could be a 2, 4, or 6, over the total number of ways, which is 6, and then again you would always reduce that to a simplified fraction of 1/2 in this case. So the event would be rolling an even dice. The probability that event occurs would be 1/2. Let's look at the second one. It says the number of pips facing up is greater than 4. So what numbers are greater than 4? The numbers 5 and 6 are greater than 4. So if I said, what's the probability of getting it greater than 4? It is 2 of the 6 sides of the die, which simplifies to a probability of 1/3. What's the probability that the facing up is less than 20? Well, if you look, which sides of a die are less than 20? All 6 sides of a die are less than 20. So the probability of something being less than 20 when you roll a standard die would be all 6 of the 6 sides, which is a probability of 1. Remember, a probability of 1 means the event must occur. The number of pips facing up is greater than 15. Well, think about the number of ways that you could get a number greater than 15 by rolling a standard die. They use the old symbol for the empty set, that null symbol, meaning there is no possible way of getting a number greater than 15. So a possible number greater than 15, there's 0 of the 6 sides, which is a probability of 0. Remember, a probability of 0 means it's impossible to happen. So it says outcomes of some experiments are equally likely. So for instance, when you roll a die, you have the same chance of getting a 2 as you do getting a 4. So it says outcomes of some experiments are equally likely, which means the chance of any one outcome is just as likely as the chance of another. For instance, if 4 balls of the same size but different colors, red, blue, green, and white, are placed in a box and a blindfolded person chooses one ball, the chance of choosing a green ball is the same as the chance of choosing any other color ball. This only works because all 4 balls are different colors. It says, in the case of likely outcomes, the probability of an event is based on the number of elements in the event and the number of elements in the sample space. We've already seen this before again, too. It says, let n of E, if you go back to what we did with sets, that's the cardinality of E, to note the number of elements in E. So that's the number of ways of what you want. And n of S be the number of elements in the sample space. So how do we find the probability of an event? It's always the number of ways what you want can happen over the total possible things that can happen. Always simplify that fraction. Again, to find the probability of an event, it's always the number of ways of what you want over the total possible.